Good morning everyone. Today in this session I will explain the heat of hydrogenation. So what is mean of heat of hydrogenation? It means by the hydrogenation of the unsaturated compound becomes to the saturation, their heat energy will be released. It means hydrogenation into the unsaturated compound and becomes to the saturated compound. In this process, their heat will be liberated. There will be heat liberated. That heat energy is called the heat of hydrogenation. Okay, right. So topic name is heat of hydrogenation. In this process, there is double bond or triple bond becomes to saturated in the presence of catalyst, platinum, palladium or nickel. It becomes to the saturated compound. At the same time, in this process, heat energy also released. So, if there is one pi bond is maybe hydrogenated, there heat energy will be 28.6 kilocalorie per mole. Kilocalorie per mole energy will be released. This minus indication is called the exothermic. We know exothermic, it means liberate the heat energy, okay, or release heat energy, that is called the exothermic. If maybe the reaction process needed heat energy, that is called the endothermic. But heat of hydrogenation is the exothermic. In this process, there is in the process heat will be released. So we indicate the minus charge. So its minus means, the indication of minus means exothermic. That is not value, negative value. That is negative is indication exothermic, means there is heat released. Okay, so here heat of hydrogenation directly proportional to number of pi bonds. Number of pi bonds. Heat of hydrogenation directly proportional to number of pi bonds. If pi bonds increases, pi bonds are increases, then automatically heat of hydrogenation increases. So pi bonds increases, at the same time requirement of H2 molecule increases. Okay, at the same time the heat energy also increases. Okay, so finally pi bonds increases, heat of hydrogenation increases. Come to the question. For example, CH2 double bond CH2, and for this question CH and CH2. In the given question, here is the one pi bond is there. How many pi bonds? One pi bond. And in this question, two pi bonds are there. So we already written here. यहाँ पर heat of hydrogenation directly proportional to number of pi bonds. Pi bonds increases, automatically heat of energy or heat of hydrogenation is increases. Hydrogenation increases, at the same time heat also release more. Okay, so for this question the answer will be heat of hydrogenation. For second one is more. Heat of hydrogenation in the given question, which is more, means this one, because there is in the two pi bonds are there, but in this question one pi bond is there. This heat of hydrogenation directly proportional to number of pi bonds, okay, but this is for exception for the aromatic compounds. Aromatic compounds, exception aromatic compounds. In the aromatic compounds, we can explain the resonance energy. So that's why there is exception of aromatic compounds for the heat of hydrogenation. Okay, right. This is the first case. In this case one, there is pi bonds increases, automatically heat of hydrogenation is increases, but exception for the aromatic compound. I will give the second question. Here is like this question: heat of hydrogenation which is high. This first one is the heat of hydrogenation is more, because here is the pi bonds 2, but here is the pi bonds 1. So pi bonds संख्या बढ़ गया है तो heat of hydrogenation बढ़ेगा. So come to the next question. This is the first, this is the second, this is the third. Here is 1 pi bond, here is 2 pi bonds, here is 3 pi bonds. Right. So what about heat of hydrogenation? Heat of hydrogenation is directly proportional to number of pi bonds. Here is 3 pi bonds. So pi bonds increases, hydrogenation increases. At the same time, heat energy also increases. That heat energy is called the heat of hydrogenation. It means hydrogenation into the alkenes or alkynes to saturated compound. So there heat energy will be released. That is we call the heat of hydrogenation. हम hydrogenation किया तो heat release होता है. That is called the heat of hydrogenation. Okay, right. Next come to the case 2. In this first case, pi bonds increase, automatically heat of hydrogenation increases. Understood? Okay. Come to the case 2. Sir, if maybe pi bonds same. In the given question, there is maybe pi bonds are same. Then what about heat of hydrogenation? Yes? Right. So, if there is pi bonds are same, if pi bonds same in the given question, maybe pi bonds same. So there is heat of hydrogenation inversely proportional to stability. Stability of alkene or alkyne. So then we have to check the stability for the given question. First you have to check the first of all how many pi bonds are there. If it is different pi bonds are there, so which is consist more pi bonds, that is heat of hydrogenation consist more. But in the given question maybe their pi bonds are same, then we have to go for the stability. Check out the stability. So stability is increases, heat of hydrogenation decreases. So I will give the one question. There is in the pi bonds are same. In the both given component, they consist of same pi bonds. Here is come to the question like this question A, and then second one question this one. There is a pi bond same now. Here is a 1 pi bond, and here is also 1 pi bond is there. But we don't say that there is a equal heat of hydrogenation. Okay. So if there is a pi bonds are same, then we have to go for the case 2, heat of hydrogenation inversely proportional to stability of alkene. So stability of alkenes directly proportional to number of alpha hydrogens. We know that. Okay. So there is alpha, here is alpha, here is alpha, here is alpha. Beside the double bond carbon, there is alpha carbon. This is alpha carbon. Here is alpha, alpha, and alpha. So here is how many alpha hydrogens? 3. Here 3 or 3. Total 9 alpha hydrogen. And here come to the 12 alpha hydrogens. 3, 3, 6, 3, 3, 6. 12 alpha hydrogens. Alpha hydrogens increases, STB increases, but heat of hydrogenation decreases. So in the given question, the stability order for this first one, this is second one. So I will mention the stability order for here. STB, which is more, very good. First is more stable than second due to there is alpha hydrogens excess. But heat of hydrogenation is opposite. 2 is greater than first. Second is greater than first. So finally, heat of hydrogenation directly proportional to number of pi bonds, exception aromatic compounds. So in that aromatic compounds, we explain the resonance energy. But resonance energy is depend on the heat of hydrogenation. But there is a different name is there, resonance energy. But here in this case, heat of hydrogenation. Okay. So but pi bonds increases, heat of hydrogenation increases. At the same time, pi bonds same. If maybe the pi bonds same. Heat of hydrogenation inversely proportional to stability of alkene. तो alkene का stability बढ़ गया है तो heat of hydrogenation बढ़ जाता है. Okay. So stability is the first is more than the second, and heat of hydrogenation second is more than the first. Understood? Right. Note down this topic. I will give the more example in the next slide. Okay. Right on. Hi student. इधर मैंने some question लेके आया. So before in the class, once you have to remember the what about the heat of hydrogenation. So heat of hydrogenation means by the hydrogenation there will be heat liberated. The process is called the heat of hydrogenation process. In this process, there is unsaturated compound becomes to saturated. So when unsaturated compounds becomes to saturated, when it will be turned to the double bond to single bond, or in the process, their heat will be releases. That heat is called the heat of hydrogenation. Okay, that heat of hydrogenation is directly proportional to number of pi bonds. So this is for the exception to the aromatic compounds, heat of hydrogenation. Okay. Pi bonds increases, heat of hydrogenation increases. Okay. And the second point, if there is pi bonds are same, then we have to check out the very good stability of component. Stability and heat of hydrogenation both are inversely proportional. Stability is more, then heat of hydrogenation is less. When we have to check out this process, if it's given pi bonds are same. In the given question, maybe there is the pi bonds is equal, then go for the stability check out. Which is getting the more stable, it consists the least heat of hydrogenation. Okay, understood? Right. So, in the first question, there is pi bonds are same. I'll give you here pi bonds that is equal to same. Feel now in this question, which is getting the high heat of hydrogenation and which is getting the low heat of hydrogenation, we can explain. So here there is in the first option how many alpha hydrogen will be there. This is alpha carbon, this is also, and this is also, and this is also. 12 alpha hydrogen is there. And second option getting the 9 alpha hydrogens. And third one 6 alpha hydrogen. This is alpha carbon, this is alpha carbon. Beside the double bond carbon is the alpha carbon. And here is there 3 hydrogen, and here is also 3. Then 3 alpha hydrogen. Totally 6 alpha hydrogen. Here is also 6 alpha hydrogens. Okay. And here is come to the question option. This is the consists 3 alpha hydrogen. This one is a 3 alpha hydrogen. Here is alpha hydrogen, there is 0. So we know that stability of alkene directly proportional to number of alpha hydrogens. Same condition. If there is pi bonds are same, if there is maybe pi bonds are is there same, then we have to check the stability directly proportional to number of alpha hydrogens. But what is the heat of hydrogenation? Heat of hydrogenation is inversely proportional to stability. So remember this one. Heat of hydrogenation inversely proportional to stability. When if there is in the given question, maybe their pi bonds are same. Okay. So the stability order, I mentioned the A, B, C, D, E, F and G. So come to the stability first. Here is a 12 alpha hydrogen. Compared to the all options, it is high alpha hydrogens. There is in the question more alpha hydrogen. So A is the first more stable, then B, then come to the option C, D and E. There is alpha hydrogens are same. Pi bonds be same, alpha hydrogen also same. So which one is getting the more stable? We know that unsymmetric is more stable than symmetric. Remember, unsymmetric is more stable than symmetric. Come to these two symmetric forms. In that, trans is more stable than cis. Okay, this is a trans, this is a cis form. So finally, unsymmetric. These two are the symmetric. In that, this is trans and that one is a cis. So unsymmetric more stable. Then symmetric. D is a trans and E. Then after F. Then after G. This is the stability of alkene. When there is in the given question, pi bonds are same. So what about heat of hydrogenation? Heat of hydrogenation is opposite to the stability, inversely proportional. So G, F, E, D, C, D, A. The order of heat of hydrogenation, this one, which is opposite to stability. Okay. So finally, heat of hydrogenation, अगर इसको हाइड्रोजनेशन किया हो तो G ऑप्शन करो, अगर हाइड्रोजनेशन किया हो तो यहाँ पर हीट एनर्जी ज्यादा रिलीज होता है. And this question getting the more heat energy released. Okay. By the hydrogenation, this one will be give the heat of energy is more. Okay. Compared to the all. समझ में आएगा? Very nice. And next come to this question. How many pi bonds will be there? First you have to check out. Here in the given question, 3 pi bonds. Here in the 2 pi bonds, and come to the, this all will be getting the 1 pi bond. I think the first option is A and B, getting the more heat of hydrogenation. So A is greater than B, then come to the this one. Here is the pi bonds same. Then what about? Very nice, stability. This is unsymmetric, this is symmetric, this is also symmetric, this is trans, this is cis, this is unsim. Okay, these two are the symmetric. So there is alpha hydrogen, here is a 0. Here is alpha hydrogen 6 and 6. Okay, like this same question. So unsymmetric stability. So here is the heat of hydrogenation. First you have to mention the stability. So first there is the pi bonds are is more. So that's why A and B is getting the heat of hydrogenation is more due to there is pi bonds excess then compared to the unsymmetric and symmetric molecules for these questions. So A, B, C and D and E and F. So second one is which is getting heat of hydrogen excess. Obviously, very good, F. Then after E, then after D, then after C. Due to here is a stability order for these 4 options C, D, E, F. And what about heat of hydrogenation? Very good, F, E, D, C. I written same one. F, E, D, C. Understood? So pi bonds increases, hydrogenation increases, at the same time heat releases excess. So option A and option B. In option A there is a 3 pi bonds, in the option B there is 2 pi bonds. So these two are getting the more heat of hydrogenation. And for these 4 options there is same pi bonds. Each one consists 1 pi bond. So then we have go for the stability order. The component which is getting the more stable and it consists the and it is to least heat of hydrogenation. Okay, which is more stable, that can liberate, very good, less heat energy. Nice. Right, next come to the next question. First you have to check the how many pi bonds there. So in their question there is pi bonds are same. In this question pi bonds same. Pi bonds that is equal to same. In the third question 2, 2, 2, 2. Okay. So where is the resonance is possible? Here is resonance. Okay, double, single, double. And here is also resonance. But here is the resonance here. Here is in the question. There is no resonance. No resonance. Okay. Either hai or either be. Here is also there. Here is also there. Double, single, double. Resonance is possible. And this question also getting the resonance also. I think there is pi bonds are same. And first, second, and third, and fourth. First, second, and fourth, except 3, third one. First, second, fourth, getting more stability. Yes, very good. Resonance to increase the stability. Okay. So resonance is the same, but in that 3, which is more stable. Here is a resonance, here is also resonance, here is also resonance, getting the same resonating structures, but which one is getting the more stable? So then we have to check the pi bonds. Pi bonds also same. Then after we have to check the number of alpha hydrogens. Okay. So here is a double bond. This is alpha, or this is also alpha, this is also, or this is also. How many alpha hydrogens are there here? 3, 5, 3, 2, 5. Total कितना? 10 alpha hydrogens is there. And what about this question? Here is alpha, respect to the double bond. This one alpha, respect to the double bond. This is also alpha. Here is one alpha hydrogen. Here is 2 alpha hydrogen. Totally 3 alpha hydrogens. Okay. There is no resonance. Okay. Automatically this one is the least stable compared to the first, second, fourth. This is come to the last in the stability order. Okay. So respect to the, this is alpha and this is also alpha, alpha. 2, 2, 4 and 3. Total 7 alpha hydrogens. Okay, here resonance is there and here is also there and here is also there. But in the given first, second and fourth option, which is highly stable, very nice. The stability is more, which one? STB, that is equal to first, then after fourth, then after second, then after first, sorry, third. Due to there is no resonance. इधर इस क्वेश्चन को रेजोनेंस नहीं है, तो इसलिए लीस्ट स्टेबिलिटी. There is no resonance, that's why it is least stability. Okay, first is more stable due to there is resonance is also there and there is alpha hydrogens 10 compared to the other options. 3 alpha hydrogens, 7 alpha hydrogens. Okay, and what about heat of hydrogenation? The heat of hydrogenation will be opposite to the stability. So then 3, 2, 4 and 1. Understood? Very good. Come to the fourth question. Okay, very nice beta. First, second, third, fourth, fifth, sixth, then seventh. Right. So this is the more stable form. And also compared to the second, third, fourth, fifth, sixth, there is pi bonds are same. For all that consists the one pi bond only. But here, how many pi bonds are there? 2 pi bonds. 2 pi bonds. So what about heat of hydrogenation? So heat of hydrogenation, first getting the highest, then come to the second, third, fourth, fifth, sixth, second, 7. So what we have to check out there? Very nice, alpha hydrogens. If there is pi bond same, we have to check the stability. So how many alpha hydrogens? 4 alpha hydrogens. How many alpha hydrogens? Here is alpha, 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 alpha. 3, 3, 6 and 4. 10 alpha hydrogens. For this question, how many alpha hydrogen? 10 alpha hydrogens. And here is the alpha, alpha, alpha. So 4 and 3, 7 alpha hydrogens. Okay? Alpha, 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 alpha. 2, 2, 2, 2. Total kitna? 8 alpha hydrogens. 4 for 8. Alpha and alpha. 3 alpha hydrogens. Alpha and alpha. 2 alpha hydrogens. Here is the 1 hydrogen, here is the 1 hydrogen. And come to the stability. So stability किसका ज़्यादा है इसमें वो चेक करना. So STB, how many alpha hydrogen there here? 10 alpha hydrogen. Third. Then after fourth, fifth, 8 alpha hydrogens. Then fourth, then second, then sixth, then seventh. So this is the stability order. First is exception. Due to here is a pi bonds are excess. So excess pi bonds, heat of hydrogen also excess. For these options, having the same number of pi bonds. So then we have to check the stability order. Stability and heat of hydrogenation both are inversely proportional. So 7, 6, second, then 4, then 5, then third. This is the order of heat of hydrogenation for the fourth question. Understood? So once again remember, listen here. Heat of hydrogenation. हीट रिलीज होता है जब अपन हाइड्रोजनेशन किया होता है. अपन हाइड्रोजनेशन किसको करना है? अनसैचुरेटेड कंपाउंड्स को करना है. डबल बॉन्ड और ट्रिपल बॉन्ड्स व्हेन दे आर comes to the unsaturated to saturate, in that process their heat will be liberated. That heat is called the heat of hydrogenation. Heat of hydrogenation directly proportional to number of pi bonds. But exception, nice, aromatic compounds. What about in the aromatic compounds? Resonance energy. Okay? If maybe their pi bonds are same, then we have to check the stability order. Stability and heat of hydrogenation both are inversely proportional. Stability ज़्यादा, heat of hydrogenation कम होता है. Which is highly stable, that consists the lower heat of hydrogenation. Okay, understood? So note down these questions. I will explain the resonance energy in the next class. Okay, right.